This is Drift, also known as Dispersion of Releases Involving Flammables and Toxics. It is an advanced gas dispersion modelling software developed and maintained by ESR Technology. This short tutorial will demonstrate the functions and features of Drift using its graphical user interface, specifically working through examples on a momentum jet dispersion of two-phase flashing release of ammonia and a dispersion from a vaporizing pool of refrigerated ammonia. When you open Drift for the first time, the interface is split into the Input tab window on the left and a graphical or tabular output on the right, with a small window at the bottom right for output program diagnostic messages such as simulation warnings. The menu toolbar provides access to common program functions to help set up your model quickly and easily. Drift comes with a Help Mouse button that shows useful information when hovering over any of the program options, as well as an online help window. Start off your Drift modelling with naming your simulation scenario with a unique and identifiable ID. This will be part of Drift's result file export. Next is to define the release. The release can be one of four types: an instantaneous release, usually to represent catastrophic vessel failure; a steady continuous release, representing a leak ignoring long wind movement; a finite duration release, representing a steady state or capped cloud size and includes a long wind travel; a time varying release, representing a fluctuating release rate with no steady state period. This is used for decaying release rates, and with inputs from ESR Technology's liquid pool spread and vaporization software, GASP. For this demonstration, we'll be modelling a two-phase flashing ammonia jet dispersion. Start off by selecting the finite duration for the release type. Continue by filling in your parameters for the starting conditions of your substance. This example release will be at a 2 meter elevation above ground level from a 25 millimeter diameter hole with a discharge coefficient of 0.61. The release is horizontal with a bearing angle of 90 degrees, measured from north, which corresponds to a release direction towards the east. Drift offers 3 different options for providing atmospheric conditions: Pasquill, hot slag, and Monin or Bukov. Other inputs on this tab are atmospheric temperature, pressure, relative humidity, Russell's length, and wind direction. The upper and lower flammability limits are loaded from Substance Property Database. The levels of interest determine levels for contour plots and hazard range tables. These are entered as a fraction of LFL, the lower flammability limit. We choose to output both LFL and half LFL. The Toxics tab is for input relating to the calculating toxic concentration and toxic dose. The toxic exponent used in calculating toxic dose is input here. For ammonia, we have selected n equals 2. The toxic dose levels corresponding to SLOD and SLOT have been added here as outdoors dose levels 1 and 2. Now that you've set up your model, simply press the play button in Drift to run it. This will produce several result outputs, denoted by these different tabs. You can look at results in both a graphical format as shown, or in a tabular format. The General tab shows the centerline concentration as a function of downstream distance. The Flammability tab shows contours of LFL on a plan view at a specific chosen elevation. The Toxicity tab shows a plan view of your SLOD and SLOT contours at the same elevation as your flammability limits. The Time History tab shows the concentration from the point of release throughout the history of the simulation. You can specify any location to view this time history. The second example scenario used in this video is the dispersion of a spill of refrigerated liquid ammonium. This utilizes imports from GASP. GASP is very similar to Drift in the way it's set up and requires similar input options. You can go back to Drift, click the GASP icon button to import, and the properties of your pool will be imported. This pool example is now ready for running. Drift predicts a flammability cloud directly above your pool. GASP imports can also be segmented. Their vaporization rate profile can be split into chunks. This better represents how the release of a cloud behaves. You will have all the same outputs, including the pool parameters imported from GASP. For inquiries about Drift, please visit our website, contact us via email, or phone us, and we will be happy to answer any of your questions. Thank you very much for listening to this short tutorial video.